All right. Well, this is going to be a little tricky because I have to be next to my sink. So you're going to see how awkward it is as I'm recording and standing here and trying to show you these activities for density. All right. So the first one is called the density of water activity. And really all it consists of, okay, here we go. Yep, you're going to see it right here. All it consists of is you got your scale here, okay? And let's see if I can set the camera nicely. So, okay. And then we're going to have the graduated cylinder. Okay, now you see how tricky this is going to be. And we're going to set, oh, well, that's not a big enough scale. I mean, the scale is, so we're going to use this scale right here. And so hopefully you can kind of get a sense of what I've got going on here. I've just got the graduated cylinder on the scale. And all I'm going to do is I'm just going to take the graduated cylinder and I'm going to just put some water in it. And then I'm going to put it on the scale. So I'm going to turn on the scale. I'm going to tear the scale. Let's see how this works. Can we do this here? Okay. All right. And then I'm going to place the graduated cylinder full of water on it, right? And then I'm going to record my data. So I've got myself 2.9. So I did this in grams, but you can make it kilograms if you want. So that'd be 292 grams. You can change the unit if you want. And then I'm looking right here, and it looks like 145 milliliters, right? So now I'm just going to fill up more, right? Oops, okay, that's great. That's going to squirt water all over my camera here. Okay, so now this volume, I'm just looking at the volume on the graduated cylinder. You all can't really see this so much, right? But you have to believe that I'm reading off the graduated cylinder, and it's like 295, and I'm getting 435 kilograms, right? Okay, so then, okay, and then what am I going to get here? Okay, so I've got 420 milliliters, and this says 560 grams, right? Okay, maybe I'll let some water out. Okay, so now I'm going to do, let's see here, 330. All right, so 330. This is 469. And then I might let some more water out, right? Okay. So then what am I going to have now? What I'm going to do now is I'm going to do, let's see, looks like 190 volume and 333, 190 volume and 333 for the mass. So let's just say that I take a graphing calculator really quickly and I go to stat, edit, and I'm just going to put in 145, 295, 420, 330, 190, right? And then I'm going to put in up here 292, 435, 560, 469, and 333, like that, right? And then let's see what the stat plots are. Yeah, that looks like a good plot to me, L1, L2. So zoom, 9. Oh, look at that. It looks like a line. And then let's do stat, calc, linreg, L1, L2. Let's store it in L1, right? Okay. So my regression equation is mass, which goes up, equals 0.974 volume plus 149, basically, right? What is the slope of the linear regression on the density activity? That's the density, right? So the density of water, which we know should be 1, came out a little bit under 1 for me. Okay, and then state the slope of the units, 1 gram per milliliter, and the accepted value, which is 1. And then what does the vertical intercept of your linear regression represent? That would be the mass, because the vertical intercept is an amount of y. The y-intercept is an amount of y, so this is an amount of mass. So it would be the amount of mass if I had no water at all. Remember that you got to get students to interpret the intercept even this late in the year. So it would be the mass if there was no volume of water. Oh, that would be the mass of just the graduated cylinder. Okay, so very easy activity, right? Now, this is a lab. I make students put it in their lab notebook. And so here's what they're going to do. What they're going to do is they're going to fill the graduated cylinder. Now, I have access to graduated cylinders that are big piece of plastic, and they go up to 250 milliliters. Okay, so I fill it about halfway with water. Okay, I fill about halfway with water. And then what I'm going to do, let me dry this off a little bit here. And then let me kind of show you my setup here. So I have these things. These are these little glass beads that you can buy a bunch of at Dollar Tree, right? And so what I'm going to do is I'm going to put, I call them marbles, but they're whatever you want to call them. I'm going to put 5, 10, 15, 20, 25, 30, 35. If you have smaller graduated cylinders, you might have students just put in one at a time, but notice how big they are. So they do have to, you've got to test them with your graduated cylinder, see if they'll actually go in. Or you can buy just actual glass marbles, like honest to goodness, glass marbles, right? Okay, so let's put this on here. Okay, so this is 59 grams. So I'm going to put on there that this is 59 grams. And then look at the setup I have here. Okay, here's the setup that I have here. I have the graduated cylinder right there. Do you see that like that? I'm going to take these 5. I'm going to put them in the graduated cylinder like that. I'm going to look at the volume, and it looks like it's 325 milliliters, right? Like that. Okay, now I'm going to put 5 more beads on the scale. It says 59 again, but that's going to be in addition to the 59 that's down there. So 59 and 59 make 118. Let's see what happens if I put this 59 grams in there. It looks like, I'm looking really closely, I'm looking right there. Okay, it looks like 350 milliliters, right? Here comes 5 more beads. I'm putting them on the scale. What does it say here? 56. So let's take 118 and add to it 56. I get 174 for the grand total mass of all the marbles. Okay, you see how that's going to go? All right, what do we got here for that? That looks like maybe 370. So 370, right, for a volume. Okay, now I'm going to take 5 more beads. I'm just taking 5 beads here. Okay, 57. So add 57 to what I had before, 231 grams of total mass of the beads. Okay, I'm going to put that in there, right? Okay, and then now it looks like that's 395. 395. Okay, 5 more beads, right? Okay, so I'm just taking 5 more beads here. I'm going to put them over here on the scale, right? You can't see it all, so I just hope you believe me. Hope you're not hearing impaired. You can just hear all this that I'm doing right here. Okay, I don't know how to do sign language or anything like that. My wife probably ought to teach me because she's hearing impaired at some point. Okay. Oh, gosh. I don't know. 415, I guess, is the volume, right? Just kind of eyeball it and move on. Okay. So 62, I'm going to add 62 like that, 349. And then we're going to add this to here. And what are we getting? We're getting a big old 445. Okay. And then, all right. Okay. 5 more beads, 59, add 59 to this show, 408 for a mass. Grand total of all the mass in there. And then the total final volume was 465, I guess, 465. So let me bring this up where you can see my data. Let me bring this up where you can see my data right there. Okay, so that's the data that I took with my glass beads. So I'm going to go to Stat Edit, and I'm going to put these in list 1, list 2, and list 3 in my calculator here. Okay, 1, 2, 3, 4, 5, 6, 7, and then we're, oops, nope, I didn't mean that. What did you mean to do to me? Okay, so list 1 times 5 makes it 5, 10, 15, 20, 25, and so forth. Okay, I have to add these, 59, 118, 174, 231, 287, 349. Can you tell I just want to get this over with? 349. I want to go home and see my children today, right? Okay. Let's see. And then this is going to be 325, 350. You can see how bad the precision is on my huge 500 milliliter super graduated cylinder that's plastic, because I'll never have glass in my classroom to save my life. Okay. I make them make all these different graphs. This is mass, which was L2, and the number of marbles L1. So this is L2 and L1. So what I'm going to do is I'm going to do, let's do a stat plot here. It is L1, L2. So then let's zoom 9. Oh, look, that line is from what we had before. So let's try doing a linreg, L1, L2, store linear regression. Okay, so then this is mass equals 11.59 N plus 0.57. Okay, so that's what that is. Now, this is list 3 versus list 1. So what I'm going to do is I'm going to change the stat plot to, let's look at the graph we got. Okay, look at that. That's that first graph. That's a pretty good line. Okay, so now we're going to change to L1 and L3. So let's change U to off and U to on, and let's get rid of U. Okay, so linreg, it'll be L1, L3. Okay, now this is volume equals 4.68 N plus 301, basically 301. Okay, now let's have a zoom 9 look at that. Okay, that's looking pretty good. Okay, I'm hoping you see this in your video right here. Okay, and then mass versus volume. Mass is L2, volume's L3. So this time, this stat plot is going to have L3 on the horizontal and L2 on the vertical. Okay, let's get rid of this. Let's turn on this stat plot, zoom 9, up and beautiful line. So then let's do linreg. This is L3 is the volume, L2 is the mass, and then, okay, oh, here we go. So mass is 2.47 volume minus 744, something like that, right? Okay, so you make the graphs on your own. All right, I want students to take away from this the lab's purpose. How are mass and volume related? So they are discovering. So I'm probably doing this. Probably the first thing I ever did was like the first day of fluids is just this as a discovery lab. So they're going to discover that the mass versus volume is linear. So mass and volume, they have a linear relationship, linear or a direct proportion. Now, technically, a direct proportion would not have any intercept. And the reason we have an intercept is because we filled up with water in the first place, right? Show how the graphs can be used to determine the density of glass and state the density of glass. Density is the slope of a mass versus volume graph. So density is a slope of mass versus volume. So our density of glass is 2.47 grams per milliliter, which would be the same thing as 2470 kilograms per meter cubed. On the AP Physics exam, they would only ever have kilograms per meter cubed, but they're used to chemistry density, so I try to give them some chemistry density. Okay, the mass of a single marble, well, that would be the slope of mass versus N, because what is the slope? The slope would be the mass per marble, right? Isn't that like grams per marble, right? Grams per marble. So the average gram marble is 11.59. So it's 11.59 grams per marble, right? And then the initial volume of water in the graduated cylinder, well, that's going to be here when there's zero marbles. Then the volume was 301, which is what I noticed. I put about 300 milliliters of water, and then this is the volume, the milliliters of each bead on average, right? Okay. And then you can do kind of whatever error analysis you want. Just remember that systematic error is a source of error that makes all of your raw data shift either high or shift low, but random error shifts it one way or another. Right. And so, for example, if there's like a meniscus or whatever kind of thing, and you read the bottom, then the volume is going to be, you ignored all this volume. So that means all your volumes are going to be smaller than they should be. Right. And so that's a source of systematic error. All of our volumes are too small. Okay. And if the volumes are too small, then that might mean that the density would be higher than it should be or whatever kind of thing. Okay. This is another version of the same lab, but all blank. So here I give the students the procedure and materials. Here I don't. So I always give my students blank lab skeletons like this, but what I will do is I will demonstrate for them the lab and give them a few hints and that kind of thing, right? All right, this is the floating bowl activity. And so what I do is I give students a bowl, and you can just get a cheap bowl like this, maybe from Dollar Tree. This right here is this is something that these little juice flavoring sugar-free packets comes in. You can get them at Aldi or Kroger or whatever kind of thing. And so I use the sugar-free packets because I'm a diabetic. And then I just save the containers because they're really, really nice. Okay, so let's say I'm going to use this right here. Okay, well, the question is, how much mass can I put in the bowl and set it afloat on the water before it sinks? Like, that's the question at hand. Well, I'm going to pretend like this is and please try to get something that looks like a rectangular prism or looks like maybe this bowl right here, which is a cylinder, right? Try not to get something conical. look at this, how it kind of tapers. Well, that's going to screw up your students if it tapers too much. But what I'm going to do is I'm going to hold this up here, and it looks like maybe 7 centimeters, and then in this direction, it looks like 11 centimeters, and then in this direction, it looks like 15 centimeters. So 7 centimeters by, what did I just say? 11 by 15, 11 centimeters by 15. And I'm going to make the students like sketch the shape and all that, but I'm not going to spend all that time. I'm trying to save you time here, right? Okay, so let me just tell you that 7 by 11 by 15 is 1155 meters cubed, centimeters cubed, right? Well, okay, so that goes down here. That's the volume of the bowl. And then what's the maximum amount of mass that can be placed in the bowl? Well, remember that the average density of the bowl has to be less than the density of water, which is 1 gram per milliliter, right? Okay, so what's the average density? Is the total mass over the total volume. Okay, in order to float, it's got to be less than 1. Now, the total mass is what I want to know, and the total volume is 1155. So then I just need a total mass less than 1155 grams. Okay, like that's what that means. This is grams per milliliter. This is milliliters. Remember, a milliliter and a centimeter cubed are the same thing. Grams per centimeter cubed, grams per milliliter, those are the same thing. Okay, so what I'm going to do, there's no back to this. Oh, yeah, there is a back to this. Okay, I'm going to put a little bit less than that amount of mass into my little boat here. And that's what this basically is, in my opinion. It's like a little crappy boat. Okay, so let's see if I can bring the camera over here. Okay, so I don't know if you're seeing that. There's the faucet head right there. So that's the water right there. Maybe I can tilt this a little bit, and you can kind of, I'm trying to frame what this looks like. You're seeing the soap dispenser right here in the reflection of the water here, the hand sanitizer the school's built after COVID. Okay, where are my masses at? I've got them right here. So I'm going to put in here 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. Okay, I thought it was 1155. All right. Oh, no, what happened? Did I lose my feed here? Let's try that again. Okay, you're seeing me here. I'm looking down at the computer. Let's go back. Okay, there we go. Okay, here we go. I'm going to float it in the water now. Okay, I'm going to go back by 1. I'm going to take 1. I'm going to go to 900. Okay, let's try 900. Will this float with 900 grams of mass in it? Oh, it's not. Okay, well, obviously I didn't do that great a job. One of the problems is you really have to balance your boat, you see. You have to balance your boat or else it tilts, right? It's called listing. Okay, it's not the same as a listing for a house. Okay, it's not the HGTV channel. Okay, so here we go. Okay, well, even with that, so I didn't do a very good job at all of taking the mass, the volume of this boat, right? So really, what I need is I need a container that has very, very straight sides, not these tapering sides. Maybe what I did was I was too generous. Like I rounded the lengths up, and if I rounded the lengths up, see, there it goes right there. Okay, so it does sink. I'll take 1. I'll start with 600 here, right? And it's dripping onto my foot here. Okay, so here we go. So here's 600 right here, and you can already see it's kind of listing. It's tilting, right? That's what it's called is listing. Okay, and then here's 700. And then here's 800. We're looking for 1155. Okay, well, that actually works. All right, so let's see. Let's do 900 here, okay? And then it sinks, right? Okay, well, that's the end of that. All right, there she blows, right? So you have to decide how you want to do that, but you really need a lot better. You might need some better bowls than I have. Okay, come on. Okay, there we go. Okay, so I've cleaned that up. All right, so what does it say on the back here? I'm just going to recite what it says on the back. Place a little bit less, explain how it goes. If the answer to 3 and the actual mass were different, give a plausible explanation. So for me, I feel like I didn't do a good job of measuring the lengths. I feel like I rounded up, and if I rounded up, then I overpromised what my boat could withstand. And then if I place the bowl and an amount of mass calculated in a vat of oil, which is less dense than water, and then in a vat of mercury. Well, mercury is more dense, so stuff is going to float easier in mercury. Oil is less dense, so your boat will very certainly sink in the oil and very certainly float in the mercury. Okay, the last one is called floating block. Okay, so the story is that you're going to get one of these blocks right here, or this. These are what are called friction blocks, but the key is that they have the little I in the end, right? Okay, and then what I'm going to get is I'm going to get a mass hanger, right? Okay, so I want to first get the density of the block. If you look at this activity, and so to get the density of the block, the first thing I'm going to do is I'm going to put the block. Everything's getting wet here. Okay, so you'll have to excuse me while my stuff gets wet here. Okay, so here we go. All right, so the mass is 208 grams, and then here are the dimensions of my block. I'm getting, okay, I'm going to try not to be so generous this time, 8.5, 9.5, and for the thickness, 3.5. Okay, so it's 8.5 by 9.5 by 3.5 centimeters. So the volume then, okay, so let me calculate that on my calculator. 8.5 by 9.5 by 3.5. Okay, so that's 282.625. And so if I do 208 over that answer, then the density, then I get 0.736 grams per cubic centimeter, right? Which is the same thing as 736 kilograms per meter cube, right? Okay. How much more mass must be set on the block so that the whole system sinks in the water? There's several ways you can answer this, but the easiest way is to just say that the density needs to exactly equal 1 to sink, the average density. So I'm going to say that the average density of 1 is equal to the total mass over the total volume. Now, what is the total mass? It's going to be 208 grams because of the block plus the extra mass I need to have. And then the total volume is 282. So then I get 282 equals 208 plus m. And then that's a little subtraction, 282 minus 208. Okay, so the extra mass I need is 74 grams. Now, I am going to, okay, here's my block, and I'm going to bring this over here. Okay, now wish me luck, everyone, because I need to get this where you can see it. Okay, yep, that's what happens every time. It screws up. Okay, so let's see if I can get the camera to quit messing up like that. Okay, now let's try and straighten this out. Let's get some good, you can see my dead boat over here, right? Okay, so I'm going to take this. This is already 50 grams. I'm going to hook it into the block, and let's set the block into the water, and clearly the block still floats. I need to scrounge up. Let me see if I can find it here somewhere. I need to scrounge up 74, so I need 24 more grams. I've got 20 grams here. Okay. Here's what I'm going to do. I'm going to take this 20 grams. I'm going to stick it on the bottom like that. So that's now 70 grams. I need 74 grams. So how am I going to get 4 grams? Well, I have some really tiny masses over here. I'm going to see one that says 4. So here is 74 grams. Oh, gosh, you're not seeing this. Okay, well, the blasted video is not working perfectly. This is kind of a crappy situation. Okay, so now you see it there. So there's the 4 grams on top. Maybe I can focus it a little bit better. Okay, and then the 70 grams is down there in the water, but you see it's still floating. So it says here, continue adding small amounts of mass to the top of the block until everything sinks. State the actual amount of mass that wound up being required. So the activity actually anticipates that it takes more than just the amount that they calculate. So I'm going to put another 10 grams on here. Still floats. Another 10, oops. Let's see if I can get it here without getting myself all soaked up here. Okay, there's another 10 grams. That's not enough. Okay, so let's do another couple of 10 grams is here. Okay, so another 10 grams. Okay, that's still floating. Okay, at this point, it's just so much that now I'm going to go back. I'm going to put my 4 right there. And then let me get a, what happened to my 40 gram suckers? Do I have any 40 gram thingies? Hang on a second, folks. I have some 20 grams here. So I'm going to use some 20 grams and some 10 grams. So just, if you all just hang on a second here. Okay, are you still seeing this? Are you still, oh, it went out of view here. Okay, so let's come over here. So I've got 20 grams, still floats. 20 grams. Oh, and what's going to happen? Oh, it's thinking about it, but it's actually still floating. Here, let me put the 20 grams over here. Oh, it's gonna tilt a little bit. Here's the 4 grams. So now we have 20 grams above the 74 that I had calculated. Here's a 10, and there it goes. Oh no, it is actually, I believe it is still floating. Let me stick my finger underneath. It is in fact still floating. I can't even believe that. So if I put another 10 on there, it definitely sinks with another 10. So can I figure out then how much then I need to put on there? What if I grab over here another 4? So I'm going to find another 4 here, and it is not yet touching the bottom, but now it is definitely touching the bottom. So really anything above, it was 74 and then plus 30 extra. So it wound up being 104 grand total grams. 104 grand total grams were required to sink this thing, okay? So 104 additional grams, okay? All right, all good. Now, the next question was, explain why the amount of metal mass was not enough to sink. Here's the reason why. Because you not only added more mass when you added mass over here, but you also added more volume. That's the key. The key is that you actually added volume as well. So as you added more metal, there was also more volume. And with more volume, you need even more mass to compensate for that. The volume of the entire block and metal system can be deduced from the total mass of the block and metal system needed to sink the system. Okay, so the mass of the block was, what was that again? Everything's getting wet for me. 208 grams. Okay, 208 grams. And then what was the total? 104 additional grams. So plus the added mass was 104 grams. So that's 312 total grams. Okay, the average density is 1. Now that we sunk, that's the mass over the volume. So that would be 312 grams over the volume. Well, we can figure out that the volume, since the ratio is 312 cubic centimeters, right? Now, there we go. Okay, from this total volume, the volume of just the metal can be calculated. Well, just the metal was 104 grams. Okay, what was the volume of the block? The volume of the block was 282.625. So let's take 312 minus 2, what was that number again? The volume? Okay, so volume was 282.625, right? Okay, now that is the volume of the metal, 29.375 centimeters cubed, right? So if I know just the mass, 104, and just the volume of the metal, then I can find out that the metal had about 3.54 grams per milliliter. Now, I'm just going to tell you right now that this metal was brass, but some of the metal was aluminum. So this is something between brass and aluminum, because I did not use the same material for all of it, right? Okay. Is it possible to change some sort of the aspect of this so the block and metal system will never sink, no matter how much metal is attached to the block? The only way that the system would float, no matter what you do to it, is if the fluid itself was denser than anything else, the wood and the metal weights. So if the density was greater than the wood of the fluid had more density than the metal weights and the wood and anything else you stick on it, then it would never ever sink. That's the answer there. Okay, well, those are some density activities. I'm going to let you figure them out on your own. Good luck.